All right, good morning. This is lesson 92, R values and correlation. Those are two things, and causation. So we've been doing this unit in statistics, so we're using numbers, a lot of math to make sense of the world around us. And statistics is actually really fun because it's very applicational math. So just like we did, like last week, we had some really great examples of like we're trying to answer questions about problems in life, like why don't teachers, or why don't kids like their teachers, or some other good examples. I'm trying to remember. Why do kids listen to so much music, right? We're trying to solve problems in your life. So we've been talking about scatter plots and lines of best fit, which has to do with correlation. And so we're trying to see, in this section of statistics, we're trying to see if two things are related to one another. Okay? Right? So, got a question for you. Is the amount of time that you're out in the sun increase your chances of getting skin cancer? Does that make sense? Would it make sense that those things are related? Yes or no? Who says yes, that those are related? Like you're going to spend a lot of time? Okay. Okay, raise your hand if you say no, they're not related. Why not? That's okay. Give me why isn't time in the sun not related to skin cancer? You just raised your hand that you don't agree. Oh, okay. Yep. Okay.
It can, because the sun is radiation, and radiation causes cancer.
Okay. Here's a counter argument. Ready? I know people that are like in the sun all the time. They're like wrinkly and red, and they don't have skin cancer, and they never did. And I know they've already passed away, and they didn't die from skin cancer. Is it possible that there's people like that out there?
Mm-hmm.
Yeah, there are, right? So, did you know, and do you know where else there's radiation? Did you know your TV has radiation? Did you know your phone has radiation? It's not as strong, but, you know. What were you going to say? Yeah, maybe that person had good sunblock, right? Maybe they're always out in the sun and they always use sunblock, right? So, but doesn't it make sense, though, if you're out in the sun a lot, you do increase your chances of getting skin cancer? But is it, like, perfect? Does going out in the sun cause cancer? Like, when you go walk out there, are you like, ah? Like, no, right? Like the video if you like my yelling. Ah. Okay, so, anyways, do you see why we do the study? So doctors or scientists will say, okay, we're going to just take a survey of people, and we're going to ask them, how many minutes a day are they out in the sun? And then we're going to ask them, do they have skin cancer? Okay? Does that make sense? Okay? So this is what it comes down to. So we're going to look at, when they do these studies, they calculate this thing called R value. R value, when you calculate it, it's between two numbers, -1 and 1. So the closer it is to -1 or 1, the stronger the relationship. If it's 0, it's not. So we're going to talk about that in a moment, okay? So, can you write this slide down for me, please? And I'll talk about it. I'll give you 2 minutes. Okay, so correlation is how strongly one variable is, which we call the independent variable, is the first one, and I use IV, is related to the dependent variable, or DV, okay? So, right, we sometimes say, like, an independent variable example is like, oh, the time you are out in the sun. The dependent variable is if you have cancer or not, okay? R value is a calculated number in math. You're not going to learn how to calculate it in here. You're going to learn how to use a calculator to do it, but there's an equation for it. And we're not going to do that in this class, but when you go to, like, you should take statistics while you're in school, because it's really interesting. Either regular sports stats that we have for here, or there's AP stats. So, really interesting class. But anyways, the R value, the answer is always a number between -1 and 1, okay? So, if you were to imagine the answer, it's like it'll fall on the number line from 0, or from -1 to 1. So the closer your answer is to the ends, the more relationship there is. So it could be a very strong positive relationship at +1, or it could be an inverse relationship at -1. Does that make sense? So remember how I talked about time in the sun and skin cancer? A lot of you said, yeah, there's a relationship. And then some of you said, no, there isn't a relationship. So if scientists were really to do a study on this that was accurate, you'd probably get a answer that's not at 1. It's probably going to be someplace in the middle here. Okay, a decimal answer. Anyways, write this down, the little number line, so you see that. So let's say that here's another slide we're going to write down. Just watch it now, and then you're going to write it down when I'm done talking. So there's 2 ways. You could have a perfect direct relationship if the R value is 1. So let's say that you had like a dot plot, and these are your dots, okay? Remember yesterday, couldn't I do a line of best fit through here? Mm-hmm. Yeah. What do you notice about the line of best fit here? Does it go through all the points? Are there any points off this line? No. So when all the points are on the line of best fit, that's when the R value is 1, okay? It's perfect, and we call this a direct relationship when the R value is 1. Okay? Make sense? Okay? When the R value is -1, let's say we had, causation. That's when one thing causes the other thing. Let me go back. Right here. I'll come back to that causation thing. We'll focus on inverse relationship. Okay, inverse relationship. Let's say we had dots that look like this. Couldn't I draw a line of best fit? Mm-hmm. Yeah. What do you notice about the line of best fit again on this one? Okay. Is it going the same direction? No, but is it going through all the dots? Yeah. So it's going through all of the dots or points, and there aren't any points off the line. That means your R value, as things increase, the dependent variable decreases. Okay, so that means the R value of -1. So let me give you an example for number 1. The more that you work, the bigger your paycheck. Would you agree? Mm-hmm. Yeah, because if you work 1 hour, let's say you make $10 an hour. If you work 1 hour, how much money should you make? $10. You work 2 hours, how much money should you make?
20.
Good. If you work 3 hours, how much money should you make?
30.
Good. Does that make sense? There's a direct relationship. Make sense? It's perfect. Does it change? If you work 3 hours, will you make $1 million? You wish, right? But that's not how it works, right? So I got another question. Does you working out any hours increase your pay? Does it cause you to get money? If you work, does it cause you to get more money? Yeah, there's causation. Working causes getting paid. Make sense? That's what causation means, okay? Here's the opposite. The bigger the engine, the less gas mileage it gets, or miles per gallon. Indirect relationship, right? The bigger the engine, the less gas mileage it makes. Does that make sense? But I got a question. Does a bigger engine necessarily give you less gas mileage in real life? No. Sometimes you got big engines and they're actually more efficient than a smaller engine, depending on the age or the technology. Okay? So let's have you talk about this and then write this down. So let's have 1 slide 2 is about direct relationship. Focus on how the line of best fit went through the lines. And since the line went through all the points, and talk about how R value is equal to 1. And use my example of causation where the more you work, the more money you get paid. And then once their ones are done, 2 solo ones about number 2, how all these points are connected by the line of best fit. Okay? Ready, set, talk. As you're writing this down, I want you to realize that the line of best fit is connected to the R value. The picture is the same thing as the number. Okay? Now, what do you think happens to your R value if there's a point that's like off of the line? What do you think happens? Is it connected or correlated as much? No, that means your R value will go closer to 0. Does that make sense? So you see this little point here, is my R value going to change much since it's not that far off? No, but what happens if your R value is like way out here? What would happen to your R value? It would change dramatically. It would start going to 0 pretty quick. Okay? Same thing here. So the more points you have off the line, let's say these are all points, the more points you have off the line, the closer your R value goes back to 0. Does that make sense, everyone?
And you don't want that?
We don't want that. That means there's no relationship, or yeah, no relationship. Okay? So let's have 1 slide 2 about that. Talk about how when points are off the line, the R value goes closer to 0. Ready? Set. Go. Okay, so don't put these points everywhere on your drawings because I just want you to know the concept. I'm going to delete all these points because I don't want that on your notes, okay? Okay, so the next slide. Look up here. Do you see this slide? When you see points all random like this, the scatter plot, can I make a line of best fit anywhere here? No, I could try, right? I could try to put I could try to like put a line like here, or I could try to put a line like this, or like this, right? But are there any points on any of these lines?
There's one.
Yeah, maybe one, but aren't there a lot of points that are way off any of these lines? Yeah, so that means that all these points off, that means your R value is going to be 0, and we could assume no relationship, okay? So one more time, let's have two solo ones actually on this one. Why this is no relationship. Ready, set, go. All right, and you could put this in your notes. You could draw this really quick, just put all the points randomly and say no relationship, R value is 0. Keep going here. So let's do, these are your steps. These are, you already wrote these down, but I'm just going to talk about them really quick. This is the two things you're going to do today. You're going to evaluate the R value. So these are the concepts I already talked about. Again, the closer it is to 1 or negative, then the more strongly correlated the two variables are. So we want the numbers to be really close to 1 or negative 1 when we talk about it. However, let's say they're not, it's not 0 or it's not 1. 0.8 or bigger is still pretty good. Okay? It means it can be a very strong relationship. And then we already talked about this, if the points are very close to the line of best fit, then there is a strong correlation. Okay? The other thing we talked about is causation. Remember I said the more you work, the more money you'll get paid. Does you working give you more money? Is that what causes it? Yeah, there's a direct relationship. Okay? Working causes more money, at least in our society. Okay? Here we go. So, numbers 1 and 2. So, just watch right now, and then you're going to write these down. So, number 1. Okay, your IV, your independent variable. Okay, we're going to evaluate the correlation between the two variables. So, our independent variable, eyes up here, focus please. The minutes of time studying for a test. Okay? DV, percent score on the test. It's telling me this is my R value. Okay? The R value is positive 0.873. Okay? So that means it's a positive relationship. And then I want to think about that in terms of our context. That means the more minutes I spend studying for the test, it means also that the higher my grade is going to be on the test. Right? So since it's bigger than 0.8 and it's close to 1, I'm going to say that this has a strong, direct relationship. Okay? And then I'm going to ask myself, does studying on a test cause a higher grade on the test? Does it cause a higher grade always? No, it doesn't cause it. So we're just going to see that there's a correlation here. Okay? That it has a strong direct relationship. Okay, that's number 1. Okay? Number 2. Number 2 says, here's our IV, the first variable. The minutes of daily exercise, the dependent variable on that, it says the person's weight in pounds. Okay? I noticed that my R value here is negative 0.659. Since it's negative, I know it's going to be indirect relationship. So I'm going to think in those terms. That means the more minutes a person exercises, the less the person's weight is going to be. Okay? Is this number close to 0.8 or close to 1? No, it's not. So I'm going to say that it's an indirect relationship, but it's not significant. I'm not going to say that there's no relationship. I'm going to say that there is not a significant indirect relationship. Okay? That's it. That's all you got to do on numbers 1 and 2. Is that easy? Super easy, right? A lot of this is just conceptual, okay? So let's have you talk right now, 1s till 2s. Continuing on number 3. Number 3. Ready? I only want you to think right now. Do not talk. Here we go. Number 3. Don't talk. Your independent variable says the size of the engine. Dependent variable, efficiency of engine in miles per gallon. The R value is negative 0.643. Think right now for 15 seconds what your answer would be. Okay? Think about R value, what kind of relationship it's going to be. 5 seconds. Okay. Talk to your neighbor. What do you think the answer should be? Go. Okay. So, direct or inverse relationship, everyone? Inverse, right? Is it strong or no relationship or not significant? Good. So we're going to write that down. We're going to say it's a not significant indirect, or I'm sorry, inverse relationship. Good. Does that make sense? Yes. It's supposed to say it's not supposed to be indirect. It's supposed to be inverse. I think I've said indirect accidentally a few times. Sorry about that. Okay? Inverse is more appropriate. Number 4. Again, 15 seconds. You're going to think to yourself. I'm going to read it out loud. Don't talk out loud. Number 4. Independent variable. The times or the minutes of daily exercise. The dependent variable is number of votes Hillary Clinton receives. So, 15 seconds. What would you write down? Ready? Set. Go. What would you write?
Strong inverse relationship.
Okay, what's the answer, everyone? No significant or no relationship or strong. I heard strong. Why is it strong?
Because it's way closer to 0.
Is that the rule? Is it supposed to be closer to 0?
It's not. Oh, wait, no, never mind. Not.
Is it strong? No. Is it significant or not significant? Is there any relationship? No. Isn't this number so close to 0? Do you agree? Yeah, so the closer it's to 0, the less relationship. So it's so close, there's no relationship. So we're going to write no relationship, okay? Was that hard? No. Now, why do we do this, okay? Let me tell you why we would want to do this kind of study. Because, so, let's say there's this person out there in America. And, you know, when Hillary Clinton started her campaign, the person's like, I love Hillary. The best. Okay, but Hillary just started the campaign, so she had no votes. She doesn't have the nomination yet. She didn't. So the person's all like, you know what? I think that if I exercise, Hillary Clinton's going to get more votes. That's what that person said to their family. Right? And the family's like, you're crazy. And the person was like, I'll prove it to you. So that day, the person's all like, you know, I don't walk usually. I'm going to go take a walk around the block. Person walked for an hour, comes home, turns on the TV. It says Hillary Clinton won all the votes for Maine. And the person's all like, see, I exercised and Hillary won. Family's like, oh, that's ridiculous. Next day, person's like, oh, I want Hillary to win so bad. So they go running, put up a sweat. 1 hour. They're wet and drenched. Come home. Turn on the TV. Hillary Clinton wins the next day. Wins more votes. What's the person thinking? It's working, right? Is that the truth, though, for everyone? No, but they're thinking that. The next day, person's a little tired. Sleeps in, gets busy, falls asleep. No more time to go work out. Turns on the TV while they're falling asleep. They're like, Hillary Clinton loses in Indiana. Bernie Sanders. Person's what? Thinking pretty guilty, right? They're guilty. They're like, oh, I didn't work out today. Hillary lost. So would you agree that there's some people out there that kind of have some weird beliefs and they connect two things together?
Mr. Ray, who do you want to win president?
Would you agree that there's people out there? Would you agree?
Yes, I agree.
Yeah, but this is why math is important. This is why R value is important, because you need to do a study. Because some people will say, oh, exercise and votes is connected. But are they really connected if I were to do a real study? Are they connected?
No.
No relationship. Does that make sense?
Yes.
Okay, good. So, and when you read the newspaper, you really want to know this because some people are like, oh, there's a relationship. And you're like, well, what's the R value? Okay? and the newspapers are like, oh, there's a direct relationship between students at San Dimas and how much money they're going to make in real life. What if someone told you that? Would you believe them? No, because you need to have an R value. Okay? Or what if I were to say, hey, you know what? If you exercise more, the more you exercise, Marky, the more hot dogs Mike's going to eat.
What's the R value?
I'll be running laps.
Right? You better think that way. Is it true, though?
Probably not.
It's not true, right? So why do we need this? It's so important to know this stuff because people are going to tell you what to think. I don't want people to tell you what to think. I want you to think about what people are saying and be like, was this a real study? What's the R value? Right?
I'm gonna ask my mom.
And you're like, this is why we have brains. We're going to think about this mathematically because we want the truth, right? Because what if someone on TV is like, you run for Hillary. Let's all run for Hillary so she gets all the votes. Are you going to believe them? No, because there's a study that says the R value is 0.
I'm gonna ask them.
Or what if you don't want Hillary to win? Will you not work out?
I would.
Wait, who do you want to win?
I don't know. Not Hillary. Okay, anyways. Maybe not.
No. There's no
Okay.
one else. They both dropped out.
Okay. Make sense? Next one. Number 5 and 6, okay? Just watch right now. We're going to do a couple more examples. So 5 and 6 I'm going to show you how to do, and then 7 and 8 you're going to do. Okay, so 5 and 6. These are like these were from the lesson yesterday. Okay, Miss Good showed you how to do these. Remember the line of best fit? Okay. So when I look at this graph, number 5, it says television size and price. The one down here is your independent variable. So television size in inches, okay? That's your independent variable. Okay? So it looks like it goes from really small to really big. So a small 20-inch TV is less than $500. And then I notice the bigger the television size, the more expensive it gets. Does that make sense? But look at this one. You got this 55-inch is $3,000. But look at this one. A bigger TV, 65 inches, $2,500. So is it always true that the bigger you get, the more expensive it's going to be?
It's just a bad TV.
We don't. It could be the brand. It could be whatever, right? But couldn't we do? Remember yesterday? Couldn't we do a line of best fit? Right. So on these problems, you can make a line of best fit in your mind, or you could do it with a computer, or you could just draw it on your piece of paper. And remember what I showed you earlier? The more points that are on the line, or close to the line, the higher the R value. So since it's going from left to right, positive, we're going to say this is a direct relationship. I got a question. Are there some points on this line?
Yeah.
Good. Are there points that are off the line but still pretty close?
Yeah.
Yeah. So I'm going to predict, because that's all we could do here, is we're going to predict that our R value is going to have a strong relationship, okay? And that it's going to be an R value that's from 0.8 to 0.99. It's definitely not 0.1, but we know that, okay? So that's number 1, okay? Make sense? Or I'm sorry, number 5. Number 6, okay? Here's another one. Age and pets owned. Okay, independent variable. We got person's age. So the older person gets, the dependent variable is the number of pets they own. So then I'm looking at this carefully. I notice all the points, are they kind of more spread out this time? Do you see that? Is there any pattern you see on this one? No. But remember what Miss Good said. If we're going to draw a line, we need to draw a line so that we have the equal number of points on each side of the line. So I'm noticing there's like a group of points here, and then there's another group of points here. So I'm going to draw a line, and I'm noticing there's 6 here and there's 6 here. Do you think it's a pretty good line that I drew?
Yeah.
Yeah. Now I got a question for you. Are there any points on this line? Yes or no? No. Okay, good. Are there points that are close to the line?
Yeah.
But aren't there also points that are far away from the line?
Yeah.
Yeah, so since there's so many points far away and that there's no real pattern here, I'm going to say that there really is no relationship, okay? I did make it positive, okay? So there might be some relationship, but it's really no relationship, okay? So let's have 2's tell the ones about number 5. How did I figure out, if I were to look at a graph and drew a line of best fit, how did I know that this had a strong relationship? And then on number 6, let's have 1 solid 2 is how we know this was no relationship, okay? Ready, set, go. Okay, number 7. We're not talking right now. Think for 15 seconds. Think about, is it a positive, inverse? Is it a strong relationship? Okay, you're not talking. You're not talking. You are thinking. Okay, talk. Go. Okay, so can you all see a line that's going through there, a line of best fit? Would you agree that it kind of looks like that? Yeah, are there some points that this line goes through? Yeah. And I got a question for you. Are there some points that are off the line?
Yeah.
Are they very far off the line?
No, there's one is.
One is, but not all of them, right? So I'm going to say that this has a direct relationship. We're going to write this down. Let's go. Write this down. And it is not as significant. Because if I were to look at this answer and this one here, you see how on number 5 all the points are all together pretty close? But look at number 7. Are all my points really close to my line? They're not as close. So I'm going to say that it's not as significant, okay? So I'm going to say it's probably, the R value is going to be, I'm going to predict it to be less than 0.8, okay? That's what I'm doing. Make sense?
Yeah.
Okay, number 8. Think for 5 seconds what your answer is going to be on number 8. Think.
Wait, he's getting the vein back.
Thank you. I have a vein, and I will use it.
It's like that telekinesis dude.
Okay, here we go. What's the answer, everyone?
No correlation.
No correlation. Okay. So there's no correlation. I'm going to say there's no relationship, which means there's no correlation, okay? Make sense? Okay, that's it. So let's talk about closure. That concludes the lesson.